I'm of roll number 21T76 and I am performing DSP digital signal processing lab number 5 which is representation of discrete time digital signal into frequency domain. Its objective is that in which this lab we have to represent we have used the representation of discrete time signal into frequency domain, resolution of spectrum, computation of magnitude, phase and power spectrum leaking and avoiding spectrum leaking. So in the first task we have to make function of my DFT and my IDFT and calculate the DFT and in inverse. So here we are given the four functions x1, x2, x3 and x4. Now we move to score. First of all we created my DFT function by giving n length and by limiting it to 0 to n minus 1 k using the formula, and then we call this function, and when we call this we will get this functions DFT of x1, DFT of x2, DFT of x3 and DFT of x4. Like similarly I make the my inverse DFT IDFT function by giving same as we given my DFT values in my DFT function, and then we run it, and then we get its inverse outputs. Like you can see that reconstructed of x1, x2, x3 and x4. Now moving towards our task number 2, in which we have to frequency resolution can be enhanced by adding trailing zeros. Calculate DFT for following signals and observe the change in frequency spectrum. So we have to calculate the DFT for the given signals. So here is our task number 2, in which we have given the signals, then calculate the DFT, and then we subplot them, and when we run it we will get this graph of magnitude spectrum 1, 2, 3, 4 up to 11, as we have given the sets of value in the function. Now moving towards our task number 3, in which we have to use MATLAB built-in functions to calculate the DFT. So in task number 3, similarly we have given one set calculated fast Fourier transform, and then we display its result. So when we run it you can see that original signal is that, DFT is that, real part of frequency spectrum is that, imaginary part of frequency spectrum is that, magnitude is that, phase is that, and inverse DFT is this 1, 2, 3, 4. As you can see the results clearly, and now the moving towards our last task, in which we have to calculate the DFT and plot magnitude spectrum, phase spectrum and power spectrum for signals. In task 2, observe the effect of zero padding. When we run the task number 2, here you can see that similarly we have given the 11 signals is calculated FFT, and then its magnitude, phase and power spectrum of each signal, and then we use a discrete plotting stamp here to plot them, and when we run it as you can see the magnitude spectrum, phase spectrum of two second signal and of first signal. So this is all for the lab number 5. Thank you so much. Allah Hafiz.